Hey, Bill Show Network. Steve Basic Architect here. And today we're going to practice stick fighting ninja style on the Bill Show Network. So grab your sticks. The instructor for today is Steve Basic Architect. No, I'm only kidding. My pointer says today we're actually going to talk about insulating a monoslope roof truss at the lower heat, right? What that detail looks like. So you can see here, we have our wood roof trusses. They're a monoslope, basically a shed roof. But the interesting thing about these are that the bottom chord isn't flat. It's not parallel to the upper portion either. The upper portion is a 4 and 12. The slope on the bottom chord is a 2 and 12. So the roof basically grows in height as we move to the other side of the roof assembly there on the high heave. So down at the low heave, roof trusses, 24 inches on center. Also note that inside here, we have a 16-inch heel height on the outside edge of the top plate, from the top of the top plate to the underside of our roof sheet. And we do that so that I can maximize the amount of insulation down at the end of that roof assembly, right? We don't want to have a whole lot of insulation in the middle of our roof and then have a taper to where we're at, R8 or R12 down at the end. Here, after we put the vent in, we're probably still at around 12 inches. So with the blown cellulose, we're going to be at R45-ish or so at the roof heave, but there's a little trick to a way that we can even bump that up a little bit more. You'll see as we progress across here, we'll see the natural progression of the detail. We have our roof or our wall sheathing, which is a Zip R9 product. That runs all the way up, but it stops short about 2 inches there. The reason for that is that we want to have a space where we can run our vent chutes down inside that soffit so that we can capture that vented air on the other side of that soffit and run it up the chute. So you can see our chutes are in. They've run down over the top of that sheathing into that soffit. And then the insulator just temporarily tucks in some fiberglass. I say temporarily, it's going to actually stay there. But they'll tuck that in to basically close off that space. And then what they do is they'll come in and they'll spray that remaining 4 inches of closed cell spray foam above the top plate, basically sealing in that roof vent there, but also adding insulation above that top plate and getting a relatively airtight assembly there with the spray foam. Now, the beauty of locking in those vents is that we avoid wind washing. Wind washing is when air can come in the soffit and short circuit the vent and blow into the insulation. It wreaks havoc in cold climates in terms of ice dams. I used to tease my good friend Peter Yost. I'd go up to Brattleboro, Vermont, and I would see ground-coupled ice dams. Yeah, an ice dam that turns into an icicle that actually is attached to the ground all the way from the roof. They do exist. But anyways, spraying that in, now the air that goes into our soffit vent only has one avenue, and that's to go up into the vent system that we designed for it and go up and then exit out the high eave up on top. Our insulators will then come by, and you can see they insulate their netting. In this case here, we're working with Advanced Green Insulation, a great company to work for. If you're up here in the Northeast, give them a call for all your insulation needs. They do pretty much every type of insulation, but very easy to work with, great team members. But then we have our blown-in insulation here. You can see that it's packed in down here at the lower edge. And then as that goes up, the top chord is going to move away from the insulation and provide that vented attic system up on the high part. So let's go back to the studio. We'll break out this specific detail, open it up. We'll talk a little bit more about it. Of course, our good friend Big Red will join in on the discussion. And that's it for Ninja Stick class today. I'll see you back at the studio.
All right. Almost like a samurai warrior unsheathing his sword. Yeah, you got Big Red. You got details. Let's not stop. Let's talk. Slope-proof insulation. Let's get after it.
All right. So, you heard me talk about flat roof insulation last time, so I grabbed the detail, grab Big Red, and let's talk a little bit about monoslope insulation here. So, give you the orientation. Here is our 2x6 wall. There's our top plate. And then on top of the top plate, you can see here's our monoslope truss. So we have that. We have our vertical member there. We have some kind of diagonal in there. And then we have our top cord there. So that's our basic truss layout. And then we want to turn this into a vented roof, of course. So we have our vent space here. And you saw the vent chutes. Those extend, I always extend them in. Probably maybe even a little further than that. It's okay to get them into the soffit there. We have our vent space there. And yeah, so we call it out, our vent there. But, you know, that's usually somewhere around 1.5 inches to 2 inches of space there. And so up here, we need to, when we get into the larger portion of the attic, we need to communicate that air. So we need to bring it in through the soffit. And you can see here, we have one of my favorites, just a simple board soffit. So we have these 5/8 inch air spaces here where we'll put a bug screen, like insect screen. They'll put it on the soffit, and then they'll put the boards up, and that just goes, the air goes in and goes up that channel. So any moisture migration up through the system is going to jump on that airstream and get vented out the top of the roof. And of course here you can see rough fascia, fascia board, subfascia, and then we have our boxed metal gutter system here that takes care of all of our water. We have our standing seam metal roof system on top of that, but today was focusing on the insulation. So you can see our wall here. We did a little flash of that Excellus product, 2 inches here, so that gives us roughly R14, and then we have an additional R15 here. Call it cellulose, and then of course R9 on the outside here, so 29 and 9. All right, yeah, 29 and 9. It's R38 for our wall system there. But continuing up, you can see we also did a flash there. And we have a pretty significant height here based on, our distance. When you fly out on the soffit there and bring that out, this geometry can start getting rather tall, which is a good thing because getting a significant amount of insulation here and, looking at this, I would say we're probably on the order of about 16 inches or so right there at the perimeter. So we spray the close cell just basically to seal that off. What we don't want is, cellulose is considered an air permeable. Now, that's arguable because I know there's some people out there that would want to argue that with me, but the industry considers it air permeable. This is not air permeable, the close cell. And so we don't want any of this air coming in and trying to go in and infiltrate our air permeable insulation. So we have to put some type of barrier system here. And so spraying just that little flash
of closed cell, it prevents what we would call or term wind washing. Right? Wind washing is having that air come up and infiltrate our insulation because it's air permeable. So we put a not air permeable insulation there. So now guess what? That air that comes into our soffit can only go up there. Only. The beauty of only is I provide the direction, and that is only the place that air can go. So it goes up. We get our nice, 16 inches here with a flash of R14 there, but even 16, that's 40. We're probably somewhere in like an R60 plus range right here at the heel. And you can see it grows. We called out 20 inches, but notice in my notes here, I call out the word settled. I didn't say 20 inches of blown-in insulation because that's what I'll get, 20 inches. I want 20 inches settled. So what that means to the insulator is he's probably going to spray in something like 22 inches plus. And he knows that when you spray that in, you're going to get some level of settling on the top edge of that insulation. And, just due to its own weight, it's going to collapse upon itself for an inch or two. So anyways, I always call for 20 inches of settled, and that of course going to get us an R76, but we're already starting out at 60 here. We're going to grow another R16 as we go up the roof there. And again, it's a fully vented roof system there, so no insulation obviously in the vents. We get that nice airstream to whisk our moisture away. Now, one of the things that we did out at the job here that you'll notice is we used a Sega product, which is their Myrex, and that's a smart vapor retarder. And that is, stapled up to the underside here. That actually works as an air barrier as well as a smart vapor retarder. So what that's going to do is while we're prepared for any moisture migration to go up here, this is kind of a filter that is going to limit the amount of moisture that goes up. So, we might have a larger amount of moisture attacking it, but only a small amount of it is going to be allowed to get through. So it's going to help diminish that and knock down the that uniform load of moisture that's trying to make its way in there. And then obviously it's just going to keep moving up and then get on that free flow, right? And the mechanism for it to move up is as moisture goes in here, right, it might be higher here than it is there. So moisture always moves from high to low. So it's going to move up and try and equalize. And as it moves up, this is going to have more moisture than that. And so this moisture is going to move up and try and equalize. So what's happening is as moisture enters the whole insulation, it is trying to equalize across here. And as it's trying to equalize, it's moving upward. And this airstream is always going to be drying that upper portion of the insulation. So as it tries to migrate, it's always, that airstream is taking this moisture and it's evacuating it. So that moisture now becomes that moisture content. And then these moistures are trying to migrate up. So that's what's actually happening in that roof system. That is, things get wet, these things dry, and then these things want to make that dry area more wet again. So basic laws of physics, high to low. Moisture moves from high to low. Anyways, and that's why we vent the roof. So there you have it. That's our sloped roof venting detail. So hopefully you enjoyed that.
Yeah. Sheathe that sword.
Anyways, hopefully you enjoyed that. right? Who doesn't like insulating roofs? Little cellulose, little vent strip, little closed cell closure. We got metal roofing up above. We got monoslope volume trusses. We got it happening. Yeah. Anyways, hopefully you enjoyed that. If you want more, Build Show Network, thousands of videos. Go check them out. Watch them 7 times. Watch them 8 times for all I care. Yeah. Enjoy. If you're still looking for more, Steve Basic Architect. Yeah, Facebook, LinkedIn, Instagram. Up there all the time, posting where I'm at, what I'm doing, checking it out, checking out job sites, checking out details. Yeah, whole ton of stuff. And if you're still looking for more, Unbuild It Podcast, Jake Bruton, Peter Yost, myself, everything building. I don't know if it even gets much better than that. But anyways, go check it out. Find out for yourself. It's on all the audio channels on YouTube. Unbuild It Podcast. Yeah. Anyways, that's Big Red. I'm Steve Basic Architect. This is the Build Show Network. And that is slope proof insulation. Until next time, long live our buildings.